Now this illustration deals with isolated switching or isolation switches in accordance with 230.204, and I suggest that you also would review for a window and so forth 490.22 and 490.40 along with this section 230.204. And then of course we have the NEC loop in the illustration that recommends for the viewer to look at figure 6-14 and chapter 16, which would be in the volume 2 of Stallcup's design book. Now notice the top of the illustration, we have a circuit breaker, and it serves as a disconnect in accordance with 230.204A, and serves also as a protective device for systems over 1,000 volts in accordance with 230.204A. Now notice the isolation switch in 230.204A is isolating the area where the worker is going to be working, and they can, there's a warning label required to be on that switch. Warning, do not disconnect under load. But after the load has been disconnected, that isolation switch is ahead of, then you could disconnect and lock and tag it out, and in accordance with Article 120, say, of 70E, NFPA 70E, and it could serve as a non-fusible disconnect for isolating an area. Now look at the next illustration below it. We have an oil switch that the contacts are immersed in oil. Then notice we have a fusible isolation switch in accordance with 230.204B, as in boy now, not A. And again, we can disconnect that switch and we can work downstream. If the all switch now needs to be served, we could have an isolation switch ahead of it, either fusible or non-fusible, that we could disconnect and isolate that whole area down. So isolation switches are used mainly to isolate equipment in areas of conductors and so forth that need to be serviced, repaired, replaced, just maintained in some manner in accordance with NFPA 70B and NFPA 70E 200.1 informational note. Now figure 6-55 is illustrating to us a non-fusible isolation switch and a fusible isolation switch and the requirements of 230.204A or B.